next speaker is Anders Berggren from Halon, and he is going to talk about can I has secure email, DANE and MTA-STS. Welcome.
Thank you. Can you hear me okay? All right, very good. So I'm just going to do a test here. Can I point it anywhere? Woohoo! All right. Last year, I was here speaking about email authenticity. That is, how can you trust the sender of an email with protocols such as SPF, DKIM, DMARC, and so on. And I kind of mentioned DANE. I had a depressing chart of DANE usage last year. This year I've been asked to speak about DANE and the state of email encryption. And this is mostly based on stuff from IETF's mailing lists, most notably from Victor Duchovny, who is one of the key players in DANE. And also, of course, lessons learned while implementing DANE in our C++ SMTP server that we developed. And also lessons learned when deploying DANE at our customers in their kind of large-scale email infrastructure structures. I'm just going to remove this for a while, because it seems to fall off. All right. So my name is Anders Berggren, and I'm 31 years old as of yesterday. I'm the CDO and a part owner of Halon, and I've been with the company since the start, roughly 13, 14 years ago. And we do this, a scriptable SMTP server, mainly used by service providers. All right. So I guess you can say that email has been kind of neglected. Perhaps we expected it to have been replaced by now. I don't know. But it's obviously still around because it works and it's decentralized, which is nice in a lot of ways. And we should probably fix it. All right. So email and TLS, and I think this is a quite big problem for email. I've noticed a fairly common misconception that people think that TLS works with email as it does for example, the web. Even people in the industry seems to believe this. And especially there was kind of an uprising in confusion when Google released a broken TLS lock in the Gmail web interface. Because it doesn't work like that. People were like, oh, I need to buy a certificate for my email server. And one does not simply get email encryption by buying a certificate for the email server. And so if we take a step back, we've had TLS for a very long time, and it's kind of a cornerstone in a lot of things we do. I mean, TLS has enabled, I don't know, online banking, finance and transactions, yada yada, e-commerce and whatnot. And we kind of take it for granted. And we have TLS on IMAP, for example. We have TLS on SMTP submission, webmail, all kind of things. And it's kind of sad that we don't have it for exchanging email. All right? So this is TLS for email. And as you can see, we have proper authenticated required TLS everywhere except between mail exchanges. We do have TLS, but it's opportunistic. And of course, that's a lot better than no TLS at all. But people kind of expect when it is TLS, people think of TLS as the secure version of TLS, not opportunistic. And this is a picture from a blog post that I wrote about it. I mean, I think it's a very good thing that Gmail added this little broken TLS lock. Super good. But it can be confusing when the icon for, you know, failed TLS verification in a web browser looks like that, and when there's no opportunistic TLS available for email, it looks like that. I think it's confusing, at least. I wrote a blog post about it, which ended up on Slashdot, which I thought was a lot of fun. And based on the comments from that post on Slashdot, people don't get this. It's obviously very hard to understand. So what is so difficult? Why is email and TLS so damn difficult? Well, first of all, we don't have one host name to verify the certificate against. You know, you do the name matching of the common name. With email, we have a domain name, we have MX record pointing at some host names, which could point at IP addresses, which has a hello or, you know, their own host name, which is something entirely different. And also, it is often hosted, so many domain names point to the same, you know, server for like web hosting companies and so on. So we need SNI for it to work. So you need to implement that with StarTLS in some way. So that's a problem. And another problem is, how do we know if we should require TLS or not? Perhaps we should implement something like HTTPS, so that the sender require TLS when they send an email or stuff like that. All of this would result in protocol changes. And some years ago, people realized that we shouldn't do this, because DNSSEC solves all of this, and of course a lot more, with the use of simple DNS records. That's all you need. I stole this picture from another Dane presentation. All right, so DNSSEC then. This is just a recap of the current state of DNSSEC deployment. I did very little research on it, but you know, the TLDs are signed, the domains are not signed, but it's okay in Sweden and the Netherlands. On the resolver part of it, it looks a bit better. Sweden is especially very green there, and I think Iceland is too. And some other countries are acceptable too. And it's nice that, for example, Google's resolver does DNSSEC. So I guess it's not good, but it could be worse. But there's a struggle, because there are a few big providers that doesn't back DNSSEC. Some are even saying that DNSSEC is bad and unnecessary. And there's of course a reason for this. It adds some complexity to DNS, and also if you're just looking at the web, if you look at HTTPS, and with Google's certificate transparency initiative and all of this, maybe we don't need DNSSEC for the web to work. But, and a shout out to Nina at our marketing team for creating this fancy illustration here. DNSSEC fixes email. If you're thinking about doing DNSSEC or want to ask somebody at your company to do DNSSEC, don't try to convince them because it's good for the web or whatever. Do it for email. Do DNSSEC for email. Because DNSSEC makes the authenticity part a lot better. You know, DKIM, putting signatures in your DNS, is obviously going to be a lot better if you have DNSSEC. And also, it gets us TLS. Finally, TLS for email. And Dane answers all of the questions that we had on the previous slides in a very, I think, elegant way. How should we verify the certificate? Well, it's specified by a DNS record. Should we require TLS? Well, it's also specified by a DNS record. Very simple, very elegant. And in order to understand Dane, it's good to know that DNSSEC is what does the heavy lifting for Dane and email. And there's no changes to the SMTP protocol, which is very nice for deployments. Very straightforward implementation, which is nice because then implementers get it right. And there's no out-of-band communication, which is, of course, a very nice thing. When you're dealing with SMTP, you don't want to add too much stuff on top of it. So, Dane was, the RFC was published in 2012. Postfix got support by Victor Duchovny in 2014. We added support in 2015, and even OpenSSL got it in 2016. So, implementation-wise, it looks pretty good. And deployment-wise, it's starting to happen things. A few things have happened in the last weeks and months, which is very, very nice for Dane. First of all, the Email Made in Germany initiative, which is a consortium of big telcos in Germany, like, you know, these, GMX, 1&1 and others. So they had a private club of secure email, and they mandated Dane just, I think, a few months ago. So now we have a few very big providers using Dane. Also, we have been, let me say, encouraging DNS providers not to give serve fails when you ask for Dane records. And since the last few weeks, no major DNS providers give serve fail on TLSA records. And this is great, because that means that you can enable Dane without getting side effects such as deliverability issues. And since this happened, we have been also encouraging our customers to enable Dane. So, and since we have quite a few big web hosting providers in Sweden, we have a very good Dane verification coverage in Sweden as of now. And one of our customers, One.com, which is a Danish large web hosting provider, they were kind enough to let me extract some statistics from their Halon. And roughly 1%, a little bit more than 1% of the email traffic leaving One.com is protected by Dane. And 1% perhaps doesn't seem so much, but I think it's a quite good start. It's 1% of a lot of traffic, so it's still a lot of protected email. And if we look at the number of domains, I only had 2 data points, sorry about that, but as you can see, there's a trend. Not moving fast enough, obviously, but at least there's a positive trend in domains with Dane. And so for future deployment then, first of all, DNS providers should allow you to add TLSA records. We enabled Dane a couple of weeks ago, and we don't host our DNS ourselves, we use cloud providers. So most of the cloud providers don't support DNSSEC. The ones that does, they don't support TLSA. And when you find a provider that supports both DNSSEC and TLSA, they didn't support having an apex zone pointing at the CNAME with CNAME flattening or alias. So we needed to go through a lot of trouble to get that. So please support TLSA if you support DNSSEC. Many service providers in Sweden and the Northern Europe does DNSSEC for all the customers by default. So we have a good DNSSEC coverage among .se domains. And because with Dane, with Dane, you just need to publish DNS records for your MX. So if you have a lot of domains pointing at the same MX, let's say you're a web hosting provider, you have X number of domains and they're all pointing to your email servers. All you need to do is add 2 DNS records to your email server. Pointing at your email server. You get what I mean. All right. So the bottom line is that if you already do DNSSEC, which a lot of our customers do, All you need to do is add a few tiny DNS records to your mail server, and you have Dane. So once our customers and other people in the world start publishing Dane records for their mail servers, and they have DNSSEC signing for all their customers, the chart here will make a major bump. All right, because 45,000 domains isn't so much. Once web hosting providers start doing this, you will get, I can't say how many, but you will get a shitload of domains here. And that'll be a lot of fun. All right, so future work with Dane then. IETF have some work on adding it to user interfaces such as webmail. A partner to us, which is called Open Exchange, they have an initiative called TES, which mandates Dane. So that's also a nice thing. And they're also looking at end-to-end encryption. So what if you can't have DNSSEC or don't like DNSSEC or whatever? What should you do then? Well, obviously some people don't like DNSSEC, so they design their own protocol. And I'd say it's like Dane Lite. And it is trust on first use with a DNS TXT record. That's why I call it Dane Lite, because trust on first use is obviously not as secure as Dane and, like normal TLS. And it uses HTTPS for validation with, the normal CA architecture that we have today, Web PKI, which is out of band. And it is also per domain, not per MX. So as with Dane, you just need to add a few DNS records to your email server. With STS, you need to add, first of all, TXT records and also HTTPS endpoints for every domain. And if you have, for example, millions of domains, that might not be so much fun. Works for Gmail, might not work for everybody else. But the consensus is that MTA-STS is okay, and it's probably going to be a standard, unless it interferes with Dane. And I have a strong suspicion that MTA-STS will actually end up being a standard. Google will add this stuff to Gmail like during 2016, and Postfix is implementing a large, would say, policy engine so that you can get all of this out-of-band stuff in the Postfix MTA. So it's probably going to happen. What can we say more about that? Well, yeah, it's another standard, basically, doing approximately the same thing. So let's see how much time I have left. Not so much time. I'll probably skip end-to-end, but I think the take-home message with end-to-end is that we currently don't have spam filters that works with implicit end-to-end encryption. You can use Dane for example, PGP or SMIME, but when you get implicit end-to-end encryption, the spam filters won't be able to see the emails, bodies anymore. So spam filters, the way they work today, will stop working. So you can do end-to-end encryption with Dane, but you'll get a lot of spam once spammers figure out that they can bypass the spam filters. So it's kind of sad, but it's unfortunately the reality. And I think transport security gets us pretty far, looking at where we are today. So, summary. There was, I think a year ago, there were talks about, giving up on Dane. Because, for example, the web browsers didn't do it. The web browser said, oh, the delay is too long for looking up a TLSA record and yada yada. So that didn't happen as it looks today. But I still think Dane has a very good outlook when it comes to email and other protocols. And when you compare it to IPv6, for example, IPv6 deployment is difficult because you need to get it out on so many places and endpoints and so on. With Dane, it's a bit different because you can get a few large service providers to start doing Dane, and you will get very good coverage because the only thing that matters is between the mail exchanges. So that is basically this. Large service providers can make Dane happen. You don't need to go through the same pain as with, for example, IPv6 deployment. And I expect that we'll see a mix of Dane and MTA-STS. I even asked on the IETF UTA mailing list, since Google does DNSSEC verification, wouldn't it make sense for Gmail to do Dane verification? Even if Gmail doesn't add Dane records, they can still do Dane verification. And I did get a reply from a Google employee saying that Gmail will very likely do Dane verification within short. So I think that is also a very big win for Dane. So bottom line, I think it'll take off. I hope it will. And that's about it. Thank you very much for listening.
A speaker for you as well.
Thank you very much.
You're welcome.
Very cute.
If you have any questions, so yeah.
Okay. Thank you. Thank you for your presentation. Ben Overeiner, Netnod Labs. Not a question, but more a comment about the goodness of Dane, an email. A number of people are collaborating with NIST, the US standard organization, in running a number of experiments, interoperability experiments, with DNS vendors, software vendors. So this bind our software from Netnod Labs, but also Microsoft is participating with that. So the setup is, can we set up a mail infrastructure, DNSSEC Dane? Can there be indeed an authenticated TLS exchange between the MTAs? Also Microsoft Exchange and Outlook do participate or are part of this experiment. Thunderbird and Secure64, ISC, well, number of organizations. And also includes the SMIME OpenPGP part for end-to-end signing or encrypting email. So, and you just mentioned Google is also joining the Dane bandwagon for email. So I think it's good news coming ahead. Thanks. Thanks again.
Thank you.